When looking at the factors that affect physiologic function, we want to take into account three key factors that will really alter both positively and negatively physiological function. But as we progress through, we'll take a look at the three main ones, which are going to be temperature and the thermoregulation of the body, altitude, and how the atmospheric oxygen levels can affect physiological function, as well as hydration, which can be on its own component but also exacerbated through temperature as well as altitude. So looking at these three, we see the big key factors: temperature, altitude, hydration, or sweat loss. When you're looking at temperature, we're starting to think about the biggest thing with temperature is that the body is really trying to maintain homeostasis. So looking at how the external temperature of the environment can impact the body's temperature, as well as how the internal temperature can change due to the external temperature. Then we look at altitude. The changes in altitude can greatly affect the body, especially once you get above a certain threshold. So as you go higher up from sea level, we start to lose more oxygen in the air, which means there's less oxygen available to be breathed. This can affect the cardiovascular system, circulatory system, as well as brain and other bodily functions. Lastly, we're going to look at hydration. Hydration is required for just about all bodily functions, but especially at exercise and rest. When you're looking at hydration, we want to think about proper muscle function, waste removal, and blood viscosity. We'll start with temperature. Looking at temperature, we think about heat and cold training. Both can affect the body when you're looking at two different extremes. So we start with how the body, primary goal is to acclimate to the temperature that you're in. So we think about body acclimatization. It's not just a guaranteed, like if it's hot outside, all of a sudden you will be able to cool yourself down. It requires energy from the body. The heat training effects, if you're actively working out, or hiking, anything like that, in a hot environment, you will notice that you'll have an elevated heart rate, increased core temperature, skin temperature will increase, sweat rate will increase, and you'll also start to have vasodilation in your blood cells, which is caused so that it can bring about more blood to the surface of the skin to increase with that cooling effect, and dehydration. We're looking at dehydration again. Very important in heat to not only just make sure that you're staying clothed with loose fitting, lightweight clothing that's also brightly colored, so that way it can reflect some of the heat, as well as making sure you're replenishing water as well as electrolytes throughout the activity. Cold training effects. These can also increase heat loss due to production of heat to try to maintain that core body temperature. It can increase dehydration, especially through exhaled air. The exhaled air you have is very moist, and as you exhale into a nice cold environment, you lose a lot of moisture through your breath. Through cold training effects, you also notice you'll have vasoconstriction, which is going to be the shrinking of the blood cells, as well as potential for hormonal imbalances. Now these hormonal imbalances, these will come from altered pH. As you start to get colder, your body starts to operate at a different temperature. Your organs, your body core temperature is now going to be functioning at a slower rate. Perhaps some of the functions will not actually happen at the same speed at which they normally do, which are then exacerbated through training. Next, we're going to look at altitude, how sea level versus elevation can affect training. It takes a minimum of 2 weeks to acclimate to elevation, roughly around 7,000 feet. And before that, what you'll notice that the short-term effects are an elevated heart rate, increased blood pressure, decreased cardiac output, decreased plasma volume, as well as hyperventilation. So these 5 things are really a sign of the body is trying to pump more oxygen throughout the body due to the lack of oxygen with each inhaled breath. In addition, you'll notice that their bodily fluids will become more alkaline. With less oxygen coming in, the diffusion of oxygen and carbon dioxide in the blood and through the lungs starts to become much more alkaline, meaning there's a bit more carbon dioxide in the body, and which results in a greater amount of waste product within the body. Long-term training effects of altitude training will be an increased VO2 max, decreased cardiac output, and an increase in red blood cell production and hematocrit production, as well as increase in mitochondria and aerobic enzymes. Now, the first major key that you're going to notice with long-term training effects is that decrease in cardiac output. That's because as the body starts to adapt, you are able to you've adjusted, you've produced more red blood cells, and you have a larger hematocrit concentration in your blood, so your heart doesn't have to pump as hard or as fast to produce the same amount of oxygen throughout the body. Additionally, the increase in mitochondria and aerobic enzymes are a result of the increased production of red blood cells, which allow for greater oxygen flow, and it lowers that alkaline level in the bodily fluids. Last key point we're going to look at is hydration, electrolytes, and water. Big thing to focus on with hydration is not just during, but it's also before and after. Hydration can occur during heat and cold training. The body can lose water as well as electrolytes during heat training through sweating. It can also lose water through breathing when it's cold training out. Big thing to remember for hydration is you need to consume water and electrolytes not only after exercise, but as well as before and during. For approximately every 75 minutes that you're exercising, you should be consuming 5 to 10 ounces of water and electrolytes. After exercise longer than 1 hour, you should also consume 10 to 24 ounces of water for every pound of body weight that was lost. Looking at the enhancing factors, if we look at thermoregulation, things that can help you adjust to the temperature changes, altitude changes, and water, and hydration. Temperature changes, big way to make sure you're staying properly clothed, you have adequate hydration, nutrition, and what time of day you're going to be active in. Thinking about keeping yourself at the less than peak hours of the cold or heat, as well as wearing the proper clothing to keep you warm enough so you retain some of that heat and cold temperatures, as well as cool enough so when it's hot out you're not overly sweating. With altitude, perhaps one of the best things you can do is hydration, as well as adjust your training routine to allow your body to acclimate. And with hydration, really emphasis on that before, during, and after consumption of both water and electrolyte mixtures. The limiting factors, especially with temperature, are going to be your sweat loss, decreased evaporative cooling abilities, as well as dehydration. And when you're looking at altitude, certainly you're going to lose red blood cell count as you have less oxygen in the air. And with hydration, the longer the duration, the higher the intensity, the greater the need for more water and electrolytes. So keeping in mind, if you look at the chart, there's going to be, as the barometric pressure increases, there is greater ambient oxygen. Now that's going to be closer to sea level. So as you get higher up, there's a lower ambient pressure, which also indicates a lower percentage of oxygen within the air. The last things to remember is when you're at rest, it can also affect your body just the same. Looking at temperature as well as altitude, big things to remember on temperature regulation as you're at rest are looking at the conduction, convection, radiation. So when you're in a warm or hot and humid environment, the body will start to gain more heat. And if you're in a humid environment, it makes it even more challenging to reduce the body's core temperature because the evaporative cooling effect is not as great. When you're in a cold environment, your body will begin to shiver to produce more heat within the body. However, this will also require more metabolic activity and cost more energy of the body. At altitude, there's an increased blood pressure, elevated submaximal heart rate, and pulmonary hypertension for those at rest. And this will occur starting at around 3,000 feet and up to about 7,000 feet is considered moderate altitude. And once you get above 7,000 feet, every 1,000 feet, you'll start to notice greater impacts of it up to about 12 to 13,000 feet, where it becomes very challenging to have day-to-day functions. So keeping in mind all of these, the biggest thing to think about within homeostasis is the body's main goal is to maintain homeostasis both in temperature as well as in metabolic activity, acid-base concentration, and the pH concentration within the body. So thinking about how temperature, altitude, and hydration can benefit you, looking to prevent those things as best as you can by adjusting your training modality, adjusting the time of day you're working out, or adjusting what you're wearing, as well as retaining hydration both before, during, and after physical activity for optimal performance, whether you are active or just maintaining at rest.